Let's see, I'll share my screen. I'm uh, Jeff Welker, and I'm at the University of Alaska Anchorage. I also have a joint appointment with the University of Oulu in Finland. And so I spend a bit of time in both locations. I wanted to share with you today, and I appreciate the opportunity to do this, some of the water vapor isotope work that we've been doing out of Thule in Northwest Greenland. And my collaborators have been tremendously instrumental in allowing this to happen. Ben, Eric, and Pete, and several others who have been part of our program. As we're all aware, Greenland is exceedingly interesting to all of us, is a place of change, constantly in the news. This is a cover article that Joe led that some of you may have recently seen, which he was able to share with us the banding of ice along the Ingefield land area in Northwest Greenland, showing the youngest ice on the surface and the oldest ice as you get closer to the land surface there to the left. The Arctic today is tremendously different than the Arctic of the past. Franklin and his group encountered ice year-long for many years there. The Greeley expedition experienced some of that as well. But today it's a system that's changing dramatically in terms of the perennial sea ice pack and its distribution and its motion. We heard about this recently, the motion of ice in the Arctic and the extent to which the multi-year ice is really only going to be found north of Greenland and into parts of northern Ellesmere Island. And this has meant that we've all taken a real interest in the Arctic hydrologic cycle, and especially the interactions between the cryosphere, the ocean, and atmospheric transport characteristics. In our work that I'll talk a bit about today, we'll address really how the interactions between the hydroclimate, the cryosphere, and the ocean are manifested in water isotopes. And we're particularly interested in the water isotope characteristics because there's many venues in which they can tell us about. Water isotopes can reflect atmospheric transport processes. They can reflect sea ice conditions. They can also be influenced by ocean currents. They're also tremendously valuable as we look to the past. And so this is where this group and the discussions between the atmosphere group and the glacier ice group are important, because it's understanding these modern processes that allow us to look to the past and really resolve what those climates were like. And these modern water isotopes are also especially important as we calibrate GCMs, which really are the essence of making predictions and accurate forecast. Our work has been based out of Thule, again in the northwest corner of Greenland. This is a location that was used originally for the very first ice core at Camp Century. Some of you may have even been up to the ice ramp there at Camp Tudo. If you were at that ice ramp 20 years ago when we first started up there, you could walk all the way to the end of it. Today, it's been completely broken as the ice along the margin has receded. And so the ice ramp is really no longer there. We've had the good fortune of being and working at Thule since about 2003 as part of several programs. One of those which really kicked off our work there was biocomplexity. We've also had support through the Arctic Observing Network as part of the ITEX program, then also as part of Mosaic. Over the years, I'd say we've mentored maybe 100 different individuals on our research projects up there that have included pattern groundwork. You see Ron and Bernard there, as well as teams that have been there as part of summer field courses. One of the advantages of Thule in terms of a research base of operations for our work is it allows continuous operations and support from the U.S. Air Force. Some of you may know that the U.S. built air bases both at Thule and Kangerlussuaq at the Cold War era. And so these sites have provided almost continuous access for scientists, and again, have been really essential to our work up on the Greenland ice sheet and the ice coring program going back to Camp Century, but what we also have going at NEAM and Summit and other locations now. What we started in 2007 was taking advantage of some new technology, and that is laser-based capacities to continuously measure the water vapor in air that is drawn in and run through an analyzer. This is the building up above the Thule Air Base. We've given our water vapor isotope system there the name of Gandalf because he measures something that only a wizard could measure, and that is it's invisible, it's water vapor. One of the things that we've been extremely fortunate to be able to do is to collect this continuous data. And as we all know, for so many of the data sets that we have today that tell us about climate and the Earth's atmosphere, continuous data, whether it's from Mauna Loa or many of these other sites with our weather stations throughout the world or our buoy systems, it's really this continuous data that allows us to capture events that we didn't expect, to look at very strong relationships that might exist, in this case, between water vapor isotopes, temperature, wind speed, wind direction, even longer term processes like the daily, monthly, and interannual variability in climate oscillations, be it the North Atlantic or the Pacific Decadal Oscillation or the Arctic Oscillation. Thule, again, it's been time periods that we've been there. There have been a couple of real extreme events that we've been able to capture. That real super warming event that took place a couple of years ago when we had a big pulse of warm moisture made its way into the Arctic. We see big enrichments here in the middle of the graph to the right. I don't know if I can put my cursor on that, but the graph to the right is the 18.0 values. You can see that they're kind of chugging along, being pretty consistent, and then a big spike associated with the big flush of moist water coming up the Baffin Bay. Those are events that we've been able to measure and capture, which again have helped us understand the rapidity at which changes occur in the Arctic. Kyle's helped us understanding the role of atmospheric rivers and moisture transport into the Arctic. Again, Thule's able to capture those kind of events for us, which are occurring in many cases more frequently. And collectively, what we've been able to put together with the Thule program is really looking at how water vapor isotopes respond at different scales. So daily scales, synoptic scales, which are weekly and monthly, annual scales, and then interannual variability. And one of the things that we see, which we're quite excited about, is there appear to be some strong relationships between the water vapor and the different phases of the NAO. And so we've been able to really document this in a way that we haven't been able to understand the way that system influences moisture transport into, within, and out of the Arctic. The other thing that we've been focused on here in more recent times, as we've delved deeper and deeper into our time series, is really questions about the formation of sea ice and how sea ice is being reflected in the water vapor isotopes at Thule. And as an example, here are some images which are showing the west coast of Greenland up through Smith Sound there. We even heard about some of this just recently with the presentation on the breakup of the ice wall out of Nares Strait. So Nares Strait's just up to the left there in the corner. But what we begin to see is that with our high frequency measurements and our intense micrometeorological data collection, and then also what we get from satellites, is we can see that there are atmospheric wind events that really begin to influence the sea ice that is adjacent to Thule, which ends up being reflected in open water along the bay. And so we're able to actually detect that with Gandalf and very rapid changes as these sea ice conditions are changing in the spring, all through the Kennedy Channel, down through Smith Sound, and along the west coast of Greenland. Our work has also been part of Mosaic. And so we've been able to use Thule in a series of sites throughout the Arctic to really capture some of the transport processes. For instance, in the lower right-hand corner, as we have moisture that comes up out of Scandinavia across our site in Arctic Finland, passes by the polar stern sitting out there and then gets ejected out of the Arctic through the Bering Strait that we capture with measurements at Barrow and Toolik. And so this multi-site aspect is something that we're really pretty excited about, and we think it's bringing a very new perspective on the behavior of the Arctic and how the behavior is differing on the east, central, and western sides simultaneously. The other thing in terms of next steps is that we're beginning to use these very long detailed time series at different sites to compare the patterns and behaviors of the Arctic. And so on the left side here is a wavelet diagram, which really is depicting kind of the behavior of the Arctic simultaneously between Thule and, in this case, where we ever have another very long record in Arctic Finland. And our next steps really our aspirations are really thinking more and more about comparative water vapor attributes across the Arctic, using both land and ship-based platforms. We've done a little bit of this with the Healy, and we see that and now with the Polar Stern. So we really see an opportunity to fully develop that, where we match up a lot of the ice-breaking capacity across the international community, and then apply those data to reanalysis of our ice core records, for instance, and also our GCM forecasting. So with that, I think I did it in less than 11 minutes. But anyway, thank you for the opportunity to talk this morning, and I'm looking forward to the other presentations.